everyone. In this video, I'm going to show how to develop a classification tree using Analytic solver. If you remember from the introductory case, we have the Hello data. Hayden Seller, the bank manager, wants to use historical data from 500 customers to develop a classification model for determining whether or not new customers will respond to a Hello offer. He also thinks that the bank is not targeting the right customers. Therefore, Hayden plans to assess the performance of the model, and then he wants to classify 20 new bank customers as likely or unlikely to respond to a Hello offer. We will use Analytic solver to build the classification tree, and then we use this tree to score the new cases. First, click on data mining and then partitioning. Standard partitioning. The dataset is already chosen here. Make sure that the dataset is from A1 to D501. First row contains headers should be checked. And move age, sex, income, and hello under selected variables. Here, under partitioning options, choose pick up rows randomly and set seed should be selected and use the default random seed of 1, 2, 3, 4, 5. And then choose specify percentages, training set 50, validation set 30, and test set 20%, and then click OK. Analytic solver creates a new worksheet called STD partition with the partition data. With the STD partition worksheet active, choose data mining and then choose classify and then classification tree. Then you will see classification tree dialog box. In the data tab, select and move the predictor variables age and income to selected variables. And sex to categorical variables. And hello as the output variable. In the parameters tab, check the prune using validation dataset and click on the tree for scoring. Select best pruned and click done. This selection tells Analytic solver to score cases using the best pruned tree to evaluate the performance of the classification tree and score new cases. Check the show feature importance and click on the trees to display button. Check the boxes next to fully grown, best pruned, and minimum error. And then click done. This tells Analytic solver to display the full, best pruned, and minimum error trees in the results. Accept other defaults and click next. In the scoring tab, check the summary report boxes for training, validation, and test dataset. Also check lift charts box for the score test data. Under the new dataset, check the in worksheet. Under the new data WS, select Hello score in the worksheet box. These 20 cases of the new bank customers in data range A1 to C21 will be scored by the classification tree algorithm. Make sure the first row contains headers box is checked and click match by name. Accept other defaults and click finish. The CT output worksheet shows a prune log that reports the error rate depending on the number of decision trees. Here you can see on the screen. The simplest tree with the minimum validation error rate of 0.16 occurs at 3 decision nodes. To find a simpler tree with a validation error rate that is within one standard error of the minimum validation error rate, we have to inspect the tree diagrams. CT full tree shows the full tree. The full tree is quite complex with many decision nodes. CT best tree and CT minimum error tree show the best pruned and minimum error trees. This is the best tree. And here is the minimum error tree. As you realize, when you compare these two tree diagrams, you will find that best pruned and minimum error trees are the same. In this example, therefore, no simpler tree with a validation error rate that is within one standard error of the minimum validation error rate can be found. The best pruned and minimum error tree are relatively simple with 3 decision nodes and 7 total nodes if the terminal nodes are included. Here, the predictor variable in the root node is sex. Because sex is a categorical variable, Analytic solver uses the generic value set as the split value. To find out what it means, we place our mouse pointer over the root node. And you see that there is a text appear above the tree. Decision node go left if sex is from set female, go right if sex is not from said female. A number of if-then rules can be derived from the classification tree. For example, one rule is that if the customer is a male who is younger than 32.5 years old, then he will not respond to a HELOC offer. Another rule suggests that if a customer is a male who is 32.5 years or older with an income greater than 26,000, then he will respond to a HELOC offer. Finally, and perhaps more importantly, the classification tree indicates that female customers are not likely to respond to the HELOC offer. Because the validation data were used for pruning, the performance of the classification tree on new data should be assessed using the test dataset. To assess the performance of the resulting classification tree, we turn to Testing Classification Summary in the CT Test Score worksheet. The performance measures show that the model has an overall error rate of 23%, sensitivity of 0.5385 and specificity of 0.8514. Note that these performance measures are highly sensitive to the cutoff value used. In this example, the default cutoff value is 0.5. If we lower the cutoff value, more cases will be classified into the target class, resulting in different values for the performance measures. Next, we are going to analyze the performance charts. The first chart is the cumulative lift chart. The blue line lies well above the red diagonal line, indicating that the classification tree performs considerably better in terms of predicting whether or not a potential customer will respond to the HELOC offer. The lift chart shows that if we send a HELOC offer to the 50 bank customers, which is the half of the test data sample size, and who have the highest predicted probability of responding to the offer, we will be able to reach 22 out of 26, which is 84.6% individuals who responded to a HELOC offer. Alternatively, if we sent the offer to 50 randomly chosen customers, we would reach only 13 of the customers who responded to the offer. The next chart is decile-wise lift chart. The first 10% of potential customers selected by the classification tree, for example, include 1.92 times as many customers who would respond to the HELOC offer, compared to a random selection of 10% of potential customers. And finally, we analyze the RAG curve, and RAG curve shows that the classification tree performs much better than the baseline model in terms of sensitivity and specificity across all cutoff values. The area under the curve, AUC, is 0.771, which is closer to the optimum classifier AUC is equal to 1 as compared to the random classifier AUC is equal to 0.5. The CT new score worksheet shows the classification predictions for the 20 records of new customers. And we can copy paste this data. As shown in the prediction HELOC column, the first two potential customers are classified as not likely to respond to a HELOC offer, while the last customer is likely to respond. The post-prop 0 and post-prop 1 columns provide the predicted probabilities of the customer belonging to class 0 and class 1 respectively.